In the previous lessons, we have learned how to solve simultaneous equations using elimination, substitution, and graphical method. In this new one, can we learn how to solve simultaneous equations where one of the equations is linear and the other one is quadratic? The first step is to identify the quadratic equation and the linear one. So for example, if I have a set of equations like this, y is equals to x plus 1 is linear because none of the unknowns is raised to power 2. But x squared minus y is equals to 5 is quadratic because at least x is raised to power 2. That is the same case with this one. And the first one, y is equals to 8 minus x is linear because none, either y whole x is raised to power 2. But in the second one, is quadratic because x is raised to power 2. Then sometimes both unknowns in the quadratic equation can be raised to power 2. Like in this case, you see we have x squared plus y squared. So this is still quadratic. But this is linear because none of the unknowns is raised to power 2. So in short, a quadratic equation is an equation where at least one of the unknowns is raised to power 2 or both of them are raised to power 2. Then a linear one is an equation where none of the unknowns is raised to any power. So how do we go about solving this? We start by substitution, then we can apply factorization to get the values of x and then again the values of y. So let me show you with an example. Let me first copy this example in my board. Let us call this equation 1 and then this one equation 2. So the first step is to write one of the unknowns from the linear equation in terms of the other. But in our case, you do realize y is already written in terms of x. So now I can substitute this in the second equation where every place I have y, I'll be putting x plus 1. So now it becomes like this. X squared, this one, minus, but I already know y is x plus 1. So I can put in brackets x plus 1 like this is equals to 5. Then I open the brackets and get x squared minus this x. Then again, negative multiplied by positive is negative. So minus 1 is equals to 5. Then it becomes x squared minus x, but I can take this 1 on the other side, which now becomes 6. So it becomes equals to 5 plus 1, which is 6. So it becomes x squared minus x is equals to 6. But then I can also take this 6 here and becomes x squared minus x minus 6 is equals to 0. And that way I have a full quadratic equation only based on x alone. Then I can use factorization to solve this question. So how do we use factorization to solve this question? First, I identify the coefficients on the x here. In our case, it is 1. Then I multiply by negative 6. So it becomes negative 6. And then I identify the coefficient of x here, which is negative 1. Then I ask myself, which two numbers, when I multiply them, I get negative 6. Then when I add them, I get negative 1. So in this case, the two numbers are negative 3 and 2. Why? Because if I take negative 3, I multiply by 2, I'll get negative 6, this one. Then when I take negative 3 plus 2, I'll get negative 1, which is this one. Now that I have the two numbers, I need to substitute them here. So I'll put x squared like this, then minus this 3x, then plus 2, this 2, x minus 1 is equals, or 6 minus 1, 1 minus 6 is minus 6. Minus 6 is equals to 0. So I can factor this like this, out like this. Then I say x outside because it is common here, into brackets, x minus 3, because when I multiply x by x, it will be x squared, then minus x multiplied by 3 is 3x. Then here I can factor out 2, so I can put plus 2 here in 2. Then I say here it is x because 2 multiplied by x is 2x, minus 3 because 2 multiplied by 3 is negative 6, is equals to 0. So you see this is x minus 3, this is x minus 3, so we just pick 1. Then we also have x plus 2 here. So it becomes x plus 2 into x minus 3, like this, is equals to 0. But then this x plus 2 then should be equal to 0. At the same time, x minus 3 should also be equal to 0. So x can be equal to negative 2 when I take to the other side, or x can be equal to 3 when I take 3 on the other side. So now having these two values for x, we can find the values of y. So our y, we said y was equals to x plus 1, but I already know x. So in the first instance, when x is negative 2, y is equals to negative 2 plus 1, which is negative 1. Then when x is 3, y, because we say that y is equals to x plus 1, then when x is 3, y is equals to x, which is 3 plus 1, which is 4. So the solutions for this question become, in the first instance, when x is negative 2, y is negative 1. And then when x is 3, y is 4. And this become the solution of that question. Can we try another example? You will try example 2 and example 4, but in my case, I'll do example 3. So first, let me copy the equations in my board. Well, since we have the two equations, already we know the first one is linear because none of the unknowns is raised to n power. Then the second one is quadratic because x is raised to power 2. So the first instance is to write one of the unknowns from linear in terms of the other, but in our case seems like y has already been written in terms of x, so we just need to go to the second equation, and then where we have y, we replace with 2x plus 3. So in this case, I'll have x squared like this, minus, but I already know y is 2x plus 3, then is equals to this negative 3 here. And then I can open the brackets and I have x squared minus 2x minus 3, because this multiplied by this becomes negative 3, is equals to negative 3 again. Then this becomes x squared minus 2x. This is negative 3. If I take it on this other side, it becomes positive. So it becomes negative 3 plus 3, which is 0. So it becomes x squared minus 2x is equals to minus 3 plus 3 is 0. So let me copy it again here. X squared minus 2x is equals to 0. So I want to show you a simple way to solve this one when we don't have that value like we did in the earlier example. You see here, the other one we had like x squared minus 2x plus or minus 6. But in this one, we only have x squared minus 2x. We don't have another value, a constant here. So in this case, I can factorize it like this. Let's say x outside like this, then in brackets x, because anyway if I take x multiplied by this x, it will be this x squared, then minus this minus, here I have x, here I have 2, so I can put the 2 here such that when I take this x multiplied by 2, it becomes 2x, then I put in brackets is equals to 0, like that. Now that I have this, I can say this x here is equals to 0, and then again this x minus 2 is equals to 0. So this x minus 2 becomes, if I take 2 on the other side, it becomes positive, so it becomes 0 plus 2, which is 2. So in this equation, x can be 0 or x can be 2. But now we want to know why. So when x is 0, y is what? I can pick the linear equation and say y is equals to 2x plus 3. But when x is 0, then y becomes y is equals to 2 into 0 plus 3, which is 0 plus 3 is 3. So y becomes 3. How about when x is 2? When x is 2, it becomes y is equals to 2, but now we know x is 2 plus 3, like this. So it becomes 2 by 2 is 4, 4 plus 3 is 7. So y becomes 7. So the solution for this question becomes 0. When x is 0, we said y is 3. But then again we said when x is 3, when x is 2, sorry, when x is 2, y is 7. So this become the solutions of this question. You can try the remaining question and see if you have understood the concept. If you have any question or any problem you want us to solve, you can comment on the video and then subscribe on my channel to keep getting content like this. Bye for now. Let's meet in the next lesson.